Hello, it's Michael here. Welcome to the Joy of Code, episode 17. And today we will look back on a number of things that we have covered before and put them together to reinforce them and get a good overview over some concepts that we have briefly encountered previously. Okay, this time we start with a completely empty Greenfoot window and we will create a new project. The things that we are about to revise or review is the structure of a class. We have in an earlier episode of the Joy of Code, we've already seen this structure of a class, the general structure that every class has. We have seen there's a comment and a class header, and then there are methods between those curly brackets in the body of the class. And I have also mentioned at the time that this is not the full story, but in fact there are also fields and constructors potentially in the body of the class, and these are optional. So in the early examples we didn't see them, and when I showed this overview of the structure of a class, the fields, constructors and methods, at that point we hadn't actually seen fields and constructors yet, so that was a bit looking ahead. In the meantime, in the later episodes we have seen examples of fields and constructors, so we have now seen all the bits, but just to pull it together, today we will look at a complete class with all these three elements, fields, constructors and methods, to get a proper understanding of it all. Don't worry, it'll not be entirely boring and repetitive. We will also do a few things. First of all, we are creating a new scenario here that we are starting with, and I will show a few new techniques along the way as well, so you will, even if you have understood everything else so far, you will learn something new. So first of all, let's get started here. I'll create a new scenario, and I want to make a scenario with some bouncing balls, so I call it bounce. When I create the scenario, and the window goes away for a while, there it is. I first have to create a subclass. Let me make that window a bit bigger here. So I start by making a subclass of the world, and I call it my world. Do I want a background image? No, I'll just leave it without a background image. If I don't have a background image, if we compile, you will see what happens. You just get a white background by default. Okay, so here I've got a world, and if we look into it, that is, if I open the editor, we see that here is the normal class skeleton that has just default comment, the class header for my world as a subclass of world, and here it's got a default constructor. So here, remember, the name here is the same as the name of the class, so that is not a method, it is a constructor that defines the size of the world. So I've got a world here by default that's 600 by 400 cells, and every cell is just 1 pixel wide. Okay, that's good. Now I want to put a ball in here that bounces around, and as it bounces off the edges, changes color. So let's start that. I make a new subclass and I call it ball, and somewhere here I want to use these colored button images as my image. So I take the blue, button blue.png is the name of the image. There it is. I compile, and this is what it looks like. So I've got this ball here, and first of all I want to make it bounce around. So when I open the editor for this ball class, we see for actor classes the default skeleton has just an act method in the body of the class, so just one method, no fields, no constructors. Let me start by writing a bit of behavior in here. Let's say we just want to move a bit at every step, and if at world edge, then we want to turn around. Let's say we turn not quite 180, something a bit odd, 153, some slightly more random angle. And here, of course, I should have brackets for my if statement, and that at world edge I haven't defined yet. One thing actually, I have written at world edge earlier in my trick the turtle. Oops, where is it? Where's my trick the turtle? Scenarios, I can... There's my trick the turtle from my previous episodes. Instead of just writing that again, here my snake, didn't that have an advert? It had a... where was it? Turn at edge. Add world edge. There was the add world edge. Oh, it was inherited. I see. It didn't come from... It came from animal. My animal class had a add world edge method here. So, code reuse. If you have a useful method in an earlier class, use it again. You don't have to write it every time again. So I'm copying that out. I close it. And I close this. So here I have my add world edge method that checks whether I'm at the edge of the world. So if I'm at the edge of the world, I turn around. This is all not new. Let's put the ball in. Let's make it. Let's have it run and see it bounces around. Okay, so we have a bit of behavior. So as far as our class structure goes, if we look, at the here the contents of the body of the class, fields, constructors, methods. So far we have two methods: no constructor, no field. We have the act method and we have the add world edge method. Okay, so that was the easy bit. Now, what I want to do, the first thing I want to do is I want the ball, when I set it into the world. So if I put a ball into the world, at the moment it always starts off going exactly to the right, because the rotation of any new object that you put into the world is always 0 degrees, and 0 degrees is facing exactly right. So every time I put a ball in, it will go exactly right at the beginning. I want to change this. I want to be able to put a ball in here. So I go to the world class and I want to put a ball in automatically. So here I just say add object, new ball, and I add it in the middle of the world, that is at 300, 200. So here I'm adding an object. So now if I do this, I compile this, the object gets added automatically, because when the world gets created, when I compile, the world gets created, and when the world gets created, the constructor of the world executes, and the constructor of the world adds a new ball automatically. So when I do this, I still have the behavior that it moves off exactly to the right. I want the direction that the ball starts off in to be definable by the creator of the ball. So here, the creator of the ball is here. That's where the ball gets created. We see here that the ball, when we create a new ball, there is an empty parameter list. So there are actually parameters being passed to the ball at creation time. These are parameters being passed to the constructor. Now that might seem odd, because if you look at the ball, we don't have a constructor. There is one detail that I haven't told you yet, and that is every class in Java has a constructor. And if you don't write a constructor, the system will automatically give you a constructor. And the constructor it gives you automatically, it has no parameters and an empty body. So essentially, by writing no constructor, what you're actually getting is a constructor that looks like this. That is public. It must be called ball, because the name for the constructor is not choosable. It has to be the name of the class. It has an empty parameter list, and it has an empty body. So writing no constructor is exactly the same as writing this constructor, a constructor with no parameters that does nothing. And in fact, the Java system, for every class where you don't write a constructor, creates this constructor. And that is why here, when the ball gets created, there is a parameter list, because when this ball gets created, this constructor over here is actually called and executed. Only in this case, it has no effect. It doesn't actually do anything. So every time you create a new object programmatically with the new instruction, it's always, the format is always the word new, the name of the class you want to create an object of, and a parameter list, that must match the parameter list of the constructor of that class. So every time you do that, two things happen. First, a new ball object is created, and second, the constructor of that ball object is executed with this parameter list. And so every time, remember, every time a class does not seem to have a constructor, it in fact has a constructor without parameters, and so you call it with an empty parameter list. So now I said I want to be able to specify the direction. For example, here, if I want to start the ball off going to the left, that is a direction of 180 degrees, I want to be able to pass in 180 and saying, okay, this ball should face off to the left. If I try to compile this now, this will not compile. It will tell me it cannot file a constructor of the format ball int. So it's telling me it doesn't find a constructor for ball that expects an int parameter. And instead of fixing it here, I want to fix it over there. I want to now create a constructor that has an int parameter that I call direction. And then I put here set rotation to my direction. So here, set rotation is a built-in method of the actor class. So every actor, including my ball, has the set rotation method that sets the rotation in that direction. Now if we compile this and I run this, it goes to the left. And now here, so you see, now we have written a constructor. The constructor, the purpose of the constructor is to set up your object at the time of creation to be exactly the way you want it initially at the beginning when the object comes into life. And in my case, I want my object to face a certain direction. And so I write a constructor that makes that object face a certain direction. A constructor is always executed. You cannot avoid it. Every time an object is being created, implicitly also, straight after the object being created, the constructor is executed. So here you can, as a writer of the ball object, you can guarantee that your object is always initialized in the right way you want it. Why am I doing this is really I want to make the direction random. I can now here create a local variable, int, which I call direction, and I assign a random number, greenfoot.get. Oops. Where is it? Get random number. That's the one I want. Get random number out of 360 because it's out of a 360 degree circle. And then I take this, copy it, put it here. So I don't make it always face left. I make it face a random direction. What I actually want to get at later is I want to create many balls, and I want them to fly all over the place. So they should start off in different directions. Let's try that out. So now I run it and starts off that way, and I reset it. This one goes left, and I reset it again. Oh, it goes left again. That looks suspicious. Now it goes right, and right again. And it goes up there, and it goes a bit down. Okay, so it goes in different directions now. So the direction now is random. So now we are at a point out of our three elements in the body of a class. We have a class that has methods, and that has a constructor, but we don't have fields yet. We see here a constructor and two methods. Before we go on to add fields, one other remark about interactive creation. I can now, when I select this, I can now not shift click into the world anymore to create a ball, because shift clicking into the world attempts to use the constructor without parameters to create the object. And now this ball class does not have a constructor without parameters anymore. It gets this constructor without parameters automatically created only if there isn't a constructor explicitly written. So now that we have a constructor written, this ball class does not have a constructor without parameters anymore. So if I want to now construct a ball interactively, I have to right click it and see here, new ball. It shows me now that my constructor has a parameter, and if I select it and put it in, it actually also prompts me now for the parameter for the constructor so that the constructor can get executed. So I can say I want this to be 270, and then that ball, if I run it, should move upwards because 270 degrees is straight up. If I want to be able to shift click, then I do need a default constructor. A default constructor is a constructor without parameters. So I can actually have multiple constructors in a class. I can copy this, and I can say, okay, I also have a constructor without parameters. So I can have one constructor with a parameter, one constructor without a parameter. That is perfectly acceptable. And then I can say the default, what should my default direction be? Let's say 270. The default direction is up. So I say if I don't say anything else, then it should face up. And if I specify the direction, it should use that direction. So that is possible. So now, if I compile and I shift click in the world, I can use the shift click again, which uses this constructor, which means they all will be moving upwards, the ones I've interactively created, whereas this invocation here, because it uses a parameter, invokes this constructor. So multiple constructors are possible. The last thing I'm going to add now is I'm going to add a field because I want my ball to change color every time it bounces off the wall. First of all, the way I change color is just by using different images. I can do a set image here, and we see we have here a button blue image, and here are some with other colors. So let me just choose the green one, because choosing this will copy the image from the image library into my project. Okay, now if I set the image again, I have the blue and the green one in my project. I want to copy them all in. I do that by just selecting them once. Now I make it purple. I set the image again, and I take the red one, and I set the image again, and I take the yellow one. Okay, so now what this did, just setting the image to all these 5 images, is it copied these 5 images with the different colored buttons into my project. Now I want to change the color automatically of my ball when it bounces by just setting another image. Now the names are not really very helpful for it. It would be much easier if they were numbered rather than having different names. So what I'm doing here is I want to go out of here. I will open this in my file system. Oops, sorry about that. Here, let me find my bounce. There it is. So in my file system is the images folder. Here are all the images now, and what I'm doing is I'm renaming them. I'm renaming them button 0, button 1. I'm using numbers instead of the color names, and you will see in a moment why that is, because then it makes it much easier in my code to automatically change them, because I can use numbers that I just count up. So I rename them as button0.png to button4.png. As a proper computer scientist, of course, you should always start counting with 0. We don't count 1, 2, 3, 4. We count 0, 1, 2, 3, 4. 0 is the first number. So we have our images renamed. If I compile this now, we should set the image again. It will, because the name has changed. Okay, so now I can have a field here, and now I'm creating a field. A field stores the state of the object, which means it memorizes some information about the object. The information I want to memorize is which image am I currently showing. So here I say private int image number. I write that, well, I may as well spell that out properly, image number. So I am declaring a field called image number, And then in my constructor, let's go back to one constructor. I don't really need the interactive one. In my constructor, I initialize the field. And I want to start out with image number 0. So, the purpose of the constructor is to initialize your whole object. It should set the state of your object in any image where you want, and it should also always initialize every field. So every field you have here should typically be initialized in the constructor. That's the job of the constructor, is to set every field into its proper starting state. So I have said image number 1 is the first I want to do. And then I say here, if I'm at the world edge, I turn and I write change image. And change image doesn't exist. I need to write this. So here I write myself a new method. And I write public void change image. And this should change now to the next image. So I have button 0, 1, 2, 3, 4. So what I'm doing here is I want to increment the image number. I've got image number starting with 0. So I say here image number plus plus. That will increment it. So from 0 I get to 1, from 1 I get to 2. Then I have to be careful. Once I get from 4 to 5, image number 5 doesn't exist. Then I want to roll it back over to 0. So I say if now, after incrementing, image number is 5, then I want to set that back to 0. So this should count around 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. And then I set my image. And now there is a new trick that you haven't seen before. Remember the base name of the image. The base name of the image, if we look at this, was button dash and then the number dot png. The suffix here, the dot .png, is important. That is part of the name. So I could set it to image number 1 by writing something like image1.png. So this statement here would set the image to that image, except it would always set it to image number 1. I don't always want to set it to image number 1. I want to set it to the image with this image number using my variable. I can actually put that in by writing it like this. I end the string here and write plus image number plus this. This is a new construction here that we haven't seen before. It's called string concatenation. This one in green within the double quotes is a string, so that is actually the text image dash. Then using a plus after string does string concatenation, which means it just adds something else to this string. In this case, it adds the image number. So it takes the number out of this variable and then adds it to the string. So that if the image number, say, is 3 right now, this will turn into the string image-3. And then there's another plus. We add something else to that. We add then the characters .png to it. So I end up with image-3 png or image-4 png. So here I'm ending up with the different names for the images that I have prepared. Let's try to compile this, and I'm getting an error. So first thing is you should look here where the error is highlighted, change image, there's a problem with that, and then you should look at the error message down here. It says cannot find the method change image. Maybe you meant change image. Okay, there it's telling me maybe I meant this because I've misspelled it here, and it's actually not misspelled here, it's misspelled here, so I fix it there and I try to compile again. Okay, that compiles. Can close this as well. Let's try that out, compile everything, and now if we do this, oh, we're getting an exception. So here, what happened now, we got a different kind of error. we got what we saw before in the editor was a syntax error. We had written something incorrectly, so that was a syntax error is if you write your code incorrectly. Now we've got a runtime error, which means our program was running, but while it was running, something went wrong, and I'm getting a message being printed out here that looks somewhat cryptic at first. So there, it tells me a legal argument exception, file not found exception, could not find file image1.png. So it looks like I have made a mistake somehow. Let's look again at my... This was not prepared, so I don't know. I hadn't expected this. I have to really investigate now what went on. It says image1.png cannot be found. Oh, that's because it's called button1, of course. I called it image1, and that's button1. So I have actually written the name of the image file incorrectly. And that is a runtime error, which means looking at the source code was correct Java. There's nothing wrong with the code. But then, because I have written here the wrong string, at runtime, it's not actually working because I've made a mistake here. So you will occasionally get runtime errors. That is, if your code attempts to do something that's not possible, you get something like this. What you should do then, you get typically something, the terminal window pops up, you get all sorts of stuff in red printed out here. What you need to do is go to the very first line or 2 lines here. At the very beginning of this whole bunch of text is where the interesting information is. So scroll back to the very top and there read the first line or the first 2 lines. The first line tells you exactly what the problem is, and the second line tells you where it is. It says at Greenfoot image load file, so we know it was trying to load the image file. And if we look down, it says it was actually in change image in ball.java, line number 44 is where we came from. So let's fix that. This was called button 1, 2, or 3. I can close this. I don't need that anymore. I compile everything again and I run. And here, every time it bounces off the edge now, it changes color. Okay, so that's a start for another project that we can do a couple of experiments with. But in summary, the important things we have seen today is here we have a class. It has a field. The field stores some information about the current object. It has a constructor. The purpose of the constructor is to initialize the object to a sensible state when it is created. And the constructor is called always when the object is created. And we have some methods in the class. So this is a complete class with all 3 elements, fields, constructors, methods in it, as we have said before. That's enough for today. See you next time. Bye bye.